So, continuing on with quantification, the screenshot I'm showing here, this is internal to CH2M Hill right now, but it's that concept of knowing what you may want to quantify and delineating that. So what I'm showing here down this side of the screen, anything what we peg with a CH underbar is we want to be able to quantify something of each of those. So as an example, I've got electrical lighting or electrical junction boxes. There's frames doors, frames windows, that type of thing. So if there's a piece of the model that we want to know something about, we peg it as such. And what that allows is, I should start up in a second. My computer took a break too. Okay, so what that allows is, once you know what you want to quantify, then as you start placing components in the model, you're able to highlight, and this is any platform, you highlight over any one of these components, and you can generate a list of information on what those components are. So this one here is electrical power devices, and you can see a lot of the information is not filled out, but there's space to fill out all that information, because we know as a firm that that specific device, we want to know that information. We want to know the manufacturer, the wattage, the light type, the spread, that type of thing. And our electrical engineers help us to figure out, well, what do we want to know about these lighting devices? And that goes for each and every discipline. So this is just showing the list we have. And for any of these, when we select one of them, it actually shows a list of data that's available to enter. Now, some of them are robust. Like there's a lot of stuff on some of them. Others are just, here's a device, we want to know the name, or we want to know the wattage, or we want to know something. It could be any small number or any large number. So if I use a door as an example, we have in here frames doors. It's not showing on this screen. So when I click on doors, I want to know my leaf width, leaf height, frame width, frame depth, fire rating. I want to know the hardware type, whether I'm using a hardware set that's then derived by my spec, or I want to list out all my hardware. So I have exit, closer, push-pull, lock, yada yada. The whole works is in there. Then that's I think what we would call the fundamental door schedule. Then there's others, and in CH across North America, we have 50 licensed architects. And the ones in Florida will say, well, we need to know wind pressure. And I'm like, well, why? Like, well, because we have hurricanes, blah, 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 we need to know wind pressure on the doors. Okay, so we have the ability to add wind pressure. And then another architect in, I think it was in the Midwest, said, well, not only do we want to know the door number, but in that schedule we want to know the door number, the room number that it's pointing into, the name of the room it's pointing into, and all this information about the room on the door schedule, okay? So when we built it, when I click on door in this view, I've got so much information that I could fill out, and then depending on where in CH2M Hill we're doing our work, we just scale that down to what we use. So I'll never put wind pressure on my door, because we normally don't do that in Ontario. Well, I normally don't. I won't speak for everybody in case you guys do. And then others, they made us add, we want to know the detail, the head, sill, and jamb details for the doors, and they want that in the schedule. So instead of having a detail sheet saying typical head, typical sill, whatever, in the schedule itself, they want to have the detail references for the head, sill, and jamb for each and every door. So it's all facilitated, and when you saw that list of, oh my God, that's a lot of information, that can all be scaled back to, I'm only going to fill out one of these things, and I'm only going to show a schedule based on that one, or I'm going to fill out everything and show a schedule based on everything. Moving into energy analysis, and this is what I was alluding to at the beginning, we can take our model and throw it into energy and heat analysis analytical tools, and that allows us to actually meet several of the lead criteria, depending on what program, what software it is. The critical message here, I'm not an expert on the analytical tools by any means, but I do know that the CAD platforms, so Bentley, Autodesk, Graphisoft, are designed for interoperable integration with any number of these third-party applications. So if you want to analyze your luminosity effect based on whatever lighting, you can actually take your lights as modeled in your model, and if I filled out the wattage for my lights and sucked it into a lighting analytical tool, it can read what I call light, it can read what I listed as watt, and it'll do the spread. And I think it's a little more complex. I think I oversimplified it. I think it needs a little more than just watt. But that's the concept. And then BIM throughout the life cycle. So that's that concept. Again, the legal ramifications. Will this really work for specific projects? We at Seeds2M Hill, I'd argue, maybe only 5 to 10% of our projects have done this, where that model has gone from beginning straight through to the end. And the facility management piece is, that's really only happened on our water treatment plants, where we're there as design build operators, and we're actually operating that plant. So we want to know where a lot of those valves and components are. We'll use the model to integrate with the facility management programs. Space planning and management, this is what I showed at the beginning. This is BIM level 1. No matter what you draw, if you use these space planning tools, you're doing BIM by default. You put a space, you give it some length, width, and height, you've got kind of a volume. Now, it struggles if you have tapered volumes or vaulted volumes, but you get an average volume, and you can enter information based on your space. Boom, you started a BIM. And what I wanted to show, the next one, then the security and emergency response. This one we found quite a bit in our government facilities, where the clients will ask, the government will ask, use the model to show us how we can do an emergency evac, or how we can do the 9/11 responses that they developed after 9/11 in the States. The Department of Homeland Security would take the Department of Defense buildings and say, run this routine and show how we can do this protocol and show this evac procedure or this whatever inside your building. So we would actually animate our buildings to show that we can actually meet several of the requirements they placed. Okay. Use of BIM. I'm not going to pause for questions this time, there's just an hour left, so I'm going to try to get through this part quickly. When you do BIM, you have a model, a database, a spec, and info. Those are the elements that we have. The operations and maintenance information, it's always there. We don't really do much with it. And for the most part, we don't use that in the BIM, but the concept is, if I have something inside the model, I'll tag it and say, this is what makes you unique. And then you'll enter into a database where I'll say, this unique thing has all of these data values. And then I'll say, you can link to a spec and link to information. So the example, what this was derived from, was a mechanical fan. So you have the fan, it's pegged as an air handling unit or an exhaust fan or whatever it is. The information on the fan might be the required volts it needs to run, the airflow through the free area, stuff like that. And then it'll have a link to its spec in division 15 or 26 now, whatever it is. And then the information on the fan. But stepping all the way back, if I'm going to model something in BIM, how do I do it, right? So I showed you all this stuff. I hope some of it stuck, which would be good. But what does it mean? So I'm going to do a door, I'm going to do a window, I'm going to do an air handling unit, I'm going to do a column, I'm going to do a wall, a roof, whatever. What is your component, and what's required on that component? Next is you have to model this thing. So it takes up space in the X, Y, Z. It's a 3D thing. Occupy the space that it needs to be occupied. The software will make you put data on it. 80% of the data that you need is probably already there in the software. The diligence is that you fill out that data. So if I'm drawing a wall, the software wants me to say it's concrete. If I don't say it's concrete, nobody knows it's concrete. And then finally, unique stuff. Add stuff to your thing. So if I put a door, I'll put it in the model. The model will let me put some hardware information. It'll let me identify its width, height, and everything. But it wants the door number. And then it wants some unique hardware requirements. It needs a unique fire rating. I have the ability to add that inside the hardware, inside the software. So identify your component. There's several types of components. Select the appropriate application. What do you need to model this thing? And model it. Select, we call them parts and families, which is a Bentley-derived term, but it's really the select your categorization of your component. And that's the fundamental piece of, I'm modeling something, I need to say what it is before I model it. Then the BIM knows what it is, and then add the unique stuff to it. So I'm just going to walk through a couple of examples here. This is using Bentley Building, which is the MicroStation. So we decide, okay, what's my component? Well, I'm going to catalog all the doors in my facility. What do my doors need to tell me? Well, here's the typical information from a door schedule. Now, I did this long before I discovered that wind pressure can come into a door schedule and who knows what else. So really, this is an example. Your door schedule can have absolutely everything, like way more than that, or it could just have 2 or 3 things. It doesn't matter. I have hardware set in here as an example. Hardware set is based on that your Division 8 spec actually says hardware 1, here's all its particulars. If you don't do that, hardware set goes away and you have each and every single piece of hardware on there. So I'm going to choose my software, select my categorization, and place a door. The critical thing is I select my categorization. I tell the software you have to know it's a door so that I can place the door. If you don't know it's a door, nobody will know that. So then I'm going to take that door, and I use this as part of a training video in CH2M Hill. Grab that door, what information is available on that door? So we actually defined most of what we want to see in here. The software by default will have enough there for you to generate a door schedule. Then we come in here and say, I'm going to build the top part, comes by default. I'm going to place this door. I'm going to say it's 1 meter wide, 2.2 meter high. Software will know that because it's a physical component. So it drives what's called parametric data. So that parametric means you're allowed to manipulate widths and heights of components in your model. So I can click on that door and say, become 2 meters wide. The information on the top will recognize that it's 2 meters wide. I can change the frame from 100 to 150. The information on top will recognize that that frame changed. And then at the bottom, I add the unique information. So the software doesn't know what type of door finish I want. The software won't know my material, and most critical, it won't know my door ID. So I input that information as that's what'll represent my door on my schedule. And I'll know that door 10101A is this door because I placed it in the model and called it as such. And then from your model, you're able to generate door numbers, door schedules directly placed into your drawings, or door schedules placed into your specifications. And this effort here, when this is used, the benefit there is if I go and change my door number, I just change it on my door in my model. So I pull up the information, I change from 10101A to 10102A for whatever reason. It automatically updates the door number I put in my model, it updates the door schedule that's ready to get inserted into my spec. All of that is linked, and I always say, when I'm asked, why do you want to do this? Like just do the work like we've always done it. Why do I have to go and edit 10101A in my model, edit it in my plan, edit it in my door schedule, and make sure that they're all in sync? And then when I go on vacation, somebody else works on my project, edits the number in my plan, and forgets to do it in my schedule, right? At least here, everything's in sync. One spot, single source of truth for the information. Change it once, it applies for everywhere else you call upon that information. Structural steel. So you have 2 parts to structural. There's an analytical design and a physical model. So let's say we want to catalog beams and columns. So we want the structural model to tell us all the information for structural steel and structural steel columns and beams. This is the typical information that comes out of any BIM software. Oftentimes you might schedule a column by type, you might schedule a column by section type. There's various ways to do it, and this by no means prescribes how to do it, it just facilitates this is how you could do it. So when you do the model, now this is rare even for CH2M Hill because we don't have engineers who can play with us yet. if they do an analytical model, so this is a Bentley-based analytical tool. I know Revit, there's an Autodesk-based analytical tool. The concept is somebody does their analytical model. Okay, it's very simple. That's what they do this all the time. And what kills me is I'll sit beside an engineer and watch them build an analytical model, but they will not use the tool that integrates with our BIM model. And it's a struggle. So once they have that analytical model, then we start populating the physical model. And all of these components are actually brought in by the, from the analytical model. So now, when I build this model, and then the structural engineer modifies their analytical model, this can get updated. And if I change this, the analytical model can get updated. So there's a bidirectional communication between the analytical software and the physical modeling software if the two are willing to play, right? 99% of the time it saves to a hill, we're not able to do this. So the analytical model I showed we don't do, except for the one engineer who does it. And we just build this model, and it's a verbal communication back and forth. And that leads to, well, it's too difficult to change the BIM. Well, why is it too difficult to change? Well, because we're tendering tomorrow, and I just changed that beam section. Well, okay. So yeah, that's difficult, because we're not following the phases, we're not designing, we're not getting the information when we're supposed to get it, and everything's supposed to be at the end of the day. And then it's like, well, why can't you just erase that label and put the numbers I'm telling you to put? Well, you can do that, but you're going to deepen that beam, which will affect the architectural facade, which will affect the columns, the ducts going underneath. There's all the ramifications that erase and change the number, we can't do that. We should never do that, actually, even in the 2D world. Then, you have the ability to draw upon direct data that's inherent to that model and bring upon the labels for all of your columns and your beams. So there's no requirement to have a plan that calls on a beam label separate from the model because it's all coming from the same spot. Again, if I change the beam, so if I replace that column with an HSS section as opposed to that section, I'm able to automatically update both my deliverables, my plans and sections, and also my schedule. So most data software, most BIM softwares will have this data available. It all depends on what you fill out. So you always have to select a section. So by default, our column generation, our column schedules are always based on the section because you're forced to select it. How much of the rest you select is totally up to how robust of a BIM information we want. So you're able to fill out specific structural data on your column markings and your type. And that's an interesting one in that you're able to schedule each and every piece, or you can schedule clumps of like types. So if I have 10 columns that are all the same section, all the same length, I just have to schedule that I have one of them 10 times. But if all my columns are uniquely different, I probably want to schedule all 10 of them uniquely different. And it's that question of knowing this is what we want to do and applying it. And then you're able to generate reports based on all of the information that's contained within the structural model, concrete, steel, whatever you peg, whatever you identify that you want, you can get from your model. If you don't identify that you want it, you will not get it. And that's a very critical message. So if you don't care about scheduling columns, don't care about it. But if you care about scheduling doors, know that you want that and set that accordingly. I'm just going to zip through the mechanical one. Same exact concept. So you want to have a fixture, some type of equipment, ducts, anything. You want to know what information you need to identify unique for that piece of duct or that piece of equipment. So this is the mechanical tool. Any component that I place comes ready with all that information to fill out. I fill out what I need. I ignore what I don't. And the other thing to think about is the spec in here might say each and every duct needs to have a certain velocity or a certain insulation type. So if it's stated in the spec, I don't need to state it in the BIM because then we're going to contradict. But if the spec says This is just a certain duct with a material, all the rest of information will be scheduled, I'll suck it out of the bin. So it actually bridges that gap between what does the engineer architect do and what does the tech do, or the CAD guy. And what we're finding now is the tech and the architect need to work much more closely together to ensure that the information here is not contradicting the information in the architect's head, and vice versa. And then the concept here is the unique identifier. Any of this can be filled out, whatever you require, whatever you need. So bringing it back, the final step again, you get your schedule, and because all the schedules for most BIM software are Excel-based, what you don't fill out, you hide. You don't need all the stuff if you don't need to show it. If you need to show it, show it. And the schedule that you do that. BIM as a whole, I went through, okay, we want the schedules, but what's the fundamental? You just want drawings, right? So you stand back and say, okay, yeah, all that schedule stuff looked good, and I'll think about that one day once I'm able to use BIM to do what I do every day. And that's fair, right? So know in your head that, yeah, we could schedule anything, we could build all these data definitions, we can make it work, but at the end of the day, I'm going to build a model, like what we're seeing here, and I want to cut a drawing. So what we found, and I'll say it again, 50% less time to do BIM to develop simple drawings versus drawing them in 2D, and that's from my personal experience. I actually can't do a project where I don't have a model, just because for me it's a waste of time to go plan section elevation and I got to change a door in 3 locations. So this concept here is, you build the model, you have it, this is a view of the section of the model, and the tool itself has a drawing production or extraction. Every tool calls it something different, but we're basically cutting the model to make a drawing, and this is the drawing out of that model. The thing then is, once you have this, as your model updates, your drawing updates. And that maintains and continues as you move forward. So if I go in the model and modify any one of these components, not only will it appear everywhere in this view, it'll appear in every other drawing that is showing that same component. And that's the critical difference. When you've got 15 sections through a building, I don't want to go update 15 sections. I want to update my model, because my model will go and update the 15 sections. So I said rapid 2D production, and it is rapid. More often than not, we'll just go home at night, press the button, let it process all the drawings, come back in the morning, and it's there. Now we've had, and this is interesting because we're working on 2 things in our Atlanta office to apply for all of CH, is how do I get my extractions to automatically happen? So how do I make this drawing production happen by default? And how do I make PDFs? Because we've got architects and engineers who say, I don't want to see your model stuff. I want to see my drawings. And that's totally cool. We can facilitate that. So we're writing a script where overnight, everybody's done with their drawings, they go home. Our management system will actually go in there and process all the drawing production, process all the extractions. So it updates all of these cuts. And it does that for about 3 hours overnight for all disciplines on the drawing. Then it goes and does a batch PDF process. So when the engineers and architects get in first thing in the morning, they have a new set of PDFs that are based on the most current state of the model. I think that's very extreme, but the point of that is that it can be done if it's required. At any time, if you have a model, like I started doing this 6-7 years ago, I'd sit there, I'd build the model, I'd show, look, Mr. Architect, you can drive through. And then the architect will say, okay, so where's the drawing? So I started learning, okay, cut that model at any time as early as possible. Where's the drawing? Here it is, but since we're only at 30%, the drawing looks horrible, but take your drawing, I'll still show you the model. So it's that process to keep that going. And that leads me into the examples I want to show. So this is the Baltimore Army Reserve Center in Maryland. This was the one with the roof that I showed earlier. The critical thing they wanted us to do here was start with a space planning charrette. So this is the U.S. Army Corps of Engineers, and they wanted us to sit down and very quickly very quickly show them how's the building going to look, how's my space going to look. So we used the space plan to generate the model on the right, and then from the right, once they agreed that, okay, the spaces are in the right spot, they gave us the cells for the equipment, so we quickly plopped in the furniture to show them that it fits, and we generated the model. And they were very critical about the roof. So this was the one where we just had to, we went through several iterations back and forth between us and the U.S. Army Corps of Engineers to make sure that that roof was doing what they wanted and the light was actually getting into the spaces they wanted to receive the natural light. This model was part of the deliverable to the contractor at the request of the client to ensure that there was no misunderstandings with respect to where the different roof elevations were and where they weren't, and where the roof changed its pitches and everything. So this was, sorry, that was the plan. That was the roof plan I showed you before, but the model, the previous model image accompanied this roof plan to actually show them this is what we want to do. Packard, Mississippi, this was an automotive plant where they basically just wanted an interior rendering. That's all they wanted. So we sat back and said, okay, so we'll do BIM, we'll do our 2D drawings, we'll schedule what we need to schedule. I think we only did doors and windows and rooms in here. And we generated them the images based on the specs they wanted, what materials they wanted us to use. They were very particular about how the ceiling worked, so we had to make sure we had that right. And then in the plans, because they were so focused on the visualization, we decided to actually throw some of the visualizations into the plans. And you can do this because we have a model, right? So instead of, like, just imagine the side effort to generate any one of these perspectives or isometrics, whereas now you lay out, here are my 3 or 4 plans, and it's just a matter of snapping a couple of views of that model, throwing it into the same drawing. The extra effort for this is 0, because it's there. We had to do the rendering as shown in the previous image, so to get the brick and all that stuff to show on the drawing, it's a 0 effort because it was already done for the rendering. And the same goes with this image here. Because they made a space plan at the beginning, we already had the zones, so the front of house, back of house, the administrative versus the parts. And then we said, well, let's just throw in the visualization for them so they can not only see the spatial arrangement, but actually get a feeling of being inside the space. I'm not sure how effective the bottom one is, but to the client, they said, wow, this makes the plan clear. And I don't know if it makes it any more clearer, but to them it made it much more clearer. And I think mostly it was because they can get a sense of the windows in the facade, that you know, the windows here aren't touching the ground, and some of the interior. I think that's where they were driving it. But. And we were able to give them a couple of perspectives on how it works. Then these schedules were generated directly from the model as well. So here we have here was an example of us giving quantities. So again, rare. This is one of the couple projects where we've done this. The client wanted us to say, this is how many walls we have on the project. So from their perspective, it narrows that bit, right? There were liability issues with delivering this drawing, and our legal department in the States had to figure out what that meant for us. We've yet to do that in Canada or in Ontario, and I probably wouldn't want to do this unless I talked to the OAA first, just to see what they think of that. And then the other thing, now, when you talk about, I want to see a movie, right? Because there's a model, now here it says we created this movie in 15 minutes. And it's true. And it's no lie. And the reason for that is this is an unrendered, non-materialistic movie. So all this is I'm in my model, and I'm just driving, and I either hit record, and I'm just recording via Camtasia, or I use, all the BIM tools have fly-through paths. So we just would draw a path and let it run. And quite literally, the hard part is, where do I want my path to go? Because the model is here. Now, if we wanted to render it so that the materials look right, here these are the colors by our default layers. So it just let them see the difference, the back and forth nature of what's actually in the space. But we could fully render this, and the movie would not take 15 minutes, but it would take probably a day or so to process. But this still gave the client the effect of just the ability to drive through and see. We had a project in Baghdad where we had to create, there were barracks and some miscellaneous areas for the army to just rest and relax, and we had to create a protective canopy. So it doesn't look very complex, but the actual makeup of that roof was the particular part. It had to withstand a certain magnitude of bomb attacks. So the spatial layout, it was pretty simple. The Army gave us a module. This is the module we need. We need so many on this side, so many on that side, and this far in between. Done. It was as simple as that. But the design of the barrack was based on layers of, we needed a finish, we needed the structure, we needed the bomb protection, and we needed the top finish. So we used the BIM to actually build those layers and understand how they would interrelate, and hand that off to manufacturers to say, is this even doable? Right? If you can't do it, what do you suggest? And it was really a back and forth between steel and material manufacturers and us to meet the Army's requirement and also have something that could facilitate the requirement, specifically in the bomb resistance. Fort Custer Army Reserve, Missouri. This one, we started off with a spatial plan. And I like this video. It's obviously faster than normal. But the idea here was, sit down with the client and figure out, well, what do you want this building to look like? So it shows they're throwing spaces into the building, giving it some names, entering some program area. And when you enter the program area, you're able to say, I want it to be this big, how big is it actually? Quickly drew in some walls, quickly threw in some doors, and we were able to sit with the client and say, is this the program you expected? And then because we were able to use the tool, we had a schedule thrown up of the space. The space name, the area, and we could do the same for the walls and the doors. Now that ran in 15 seconds, whatever. It takes a little longer than 15 seconds, but the concept of that is, you could sit down in front of a client and go from space to what I called level 2 BIM at the beginning of the presentation within the course of a client meeting. Now, of course, you need somebody there who can use the tool, right? But with that said, it allows us to do that, and then we could take this back and from this base start to just really push the model forward. It's not a throwaway model. Everything in there is true and honest data that'll just be expanded upon throughout the course of the project. So this was the final space plan that we sent to them for agreement, and with a back and forth, this was the initial look of how the model started. And then here, or based on the option they selected, we were able to give them a complete list of the program area and action. And this is what I wanted to show. That most tools allow us to do this. So there's a program requirement where the client will say, I need 100 square feet of blah, 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 or 1,000 square feet. When we lay them all together, you might not get that 1,000, but you may get 900 or 1,100. And this shows, this is what you wanted, this is what we have, is that good? The client rubber stamps it, and away we go. The Pantex processing facility, this was an interesting project because we were consulted to come in and build a BIM. So the client, and this is the Department of Energy in the States, said to us, we procured a design, here's the contract documents, can you build a BIM? And then our first response was, why? And they said, well, we think there's going to be interferences. So we took these contract documents and we built a model and we BIMmed everything. Like this is level 4 BIM and beyond. It was so robust it was scary. A lot of work was put into it. We took the drawings. This is how the model ended up. There's 5 disciplines, so there's architectural, structural, mechanical, electrical, and then, there's 6. There's telecommunications as its own separate model. And then there was a process piping discipline as well, because there was some process transfer that had to occur inside the facility. And I'm just going to run this video. This guy here, once we had the BIM, we ran Interference Manager, and we just started counting, well, how many interferences do we have? And it went on and on and on, and we had, I think the final number is 120. Doesn't seem like a lot, but it was 120 significant. What did I say? Yeah, 120 significant interferences. So what we did then was, we took the interferences, we got our engineers and architects on it, resolved the interferences, and then modified the drawing. So here's just an example. Like here we had a major interference between the height of the structure and some of the stuff beneath. So we rectified, this is how the structure is actually supposed to be, and thus by knowing that, we then had to go and modify a whole bunch of other things on the other disciplines. So we reissued the drawings along with the BIM to the client. And I'm just going to play this guy here. If it opens. Should open.